So I thought we'd take a look at all the PCBs in the Scientist 909 calculator. And I've shot a bunch of pictures here and kind of sorted through them to pull out the best. Lighting is always an issue. So we'll start with this board. This is the Nixie tube, not the driver board, but I really think the decoder board and the multiplexing board. So the Nixie tubes on the unit are multiplexed. The Nixie tube PCB connects down on this connector here, and there's a second connector on the other side of the board that the PCB comes down onto, and all the high voltage stuff seems to happen on that upper PCB with the tubes mounted on it. You can see here these are all really common TTL devices: 74154, 7400, date codes 71, 71 again, 42nd week 71. A lot of pretty standard stuff on here. I don't know what this device here is. Date code is 7103. I don't know if it's a house marking. It's, I believe, a Fairchild part with the F here. Kind of hard to read, 900459. It's a ceramic package, I believe. Kind of an interesting device. Of course, some just 0.01 microfarad ceramic caps scattered around here. Most likely for just despiking on the power rails. It's like a pretty typical PCB layout. We've got all the horizontal runs on this side, and when you look at the back side, you'll see a lot of vertical runs as well. It's got these nice yellow capacitors here, 0.047. I don't know what, probably 10%, 250 volt. Again, this is dealing with the high voltage up to the Nixie tubes as well. You said they are multiplexed. We'll look at that on the other board. So kind of a neat little board. Kind of a view of the center of the board here with the array of transistors on it. 2, 3, 4, 5, 6. Look, there's 14 of them here. I suspect probably one transistor per Nixie tube. Can't say that definitively. Again, more TTL logic. Pretty standard stuff. You can see here the two edge connectors that the actual board with the Nixie tubes slide down onto. That board mounts kind of this board stands vertically in the chassis, and that board pushes down horizontally onto it. Nice Tektronix logo or information down here. So this had shifted to where Tektronix was manufacturing the PCBs, rather than Centra. And the other side of that same board, again, we've got another one of these, I believe, Fairchild chips. I could be wrong. TT Micrologic, perhaps, is what that logo is. It may be just a TTL device with a non-standard, 7400 series marking on it. Again, pretty much just standard 7400 logic. Notice this isn't LS logic or F. It's just all real old school early TTL logic. These are 2N5416s. Nice metal cans, nice transistors for the era. So a neat board. We can get a little closer look here at the Tektronix Incorporated assembly number, revision K, it looks like, the artwork on the board. Looking at the back of the board, we see again it's Art K, so the K revision. These boards all are keyed. There's a key slot in all the connectors, so you can't get them in the wrong place. There's some evidence of rework on the back side here. I believe maybe a capacitor's been changed here. Something's been done in here. I'm not sure what. There's a couple of really lousy looking solder joints there. I don't know if that's just flux that was spilled on there. It's hard to say, but these have definitely been resoldered. At some point, a component replaced. You can see that most of the traces here run vertically on the back of the board where they were horizontal on the front, although that's not completely true. It's a pretty typical layout for the era. We do see evidence here that this IC has been replaced, this IC has been replaced, and a couple over here, I believe. Just based on the facts, you can see what this factory soldering looks like, and you can see that something's happened here. And there's a lot of flux residue left over. It's interesting that this trace here has a heavy band of solder on it. I assume there's a via under here. It's hard to say, but that heavy band of solder does say it was kind of intended to carry a bit more current. I don't know what was supposed to be mounted here. That's interesting to see those two holes. Let's go back and see if we can determine what was soldered there. So this would be these two places here. There's a plus symbol most likely there. There may have been a capacitor in there at one time that's been removed. That's interesting. Let's get back to where we were. Where again we were seeing these two holes here that looked to have been unsoldered and part removed and not put back in. Definitely evidence of rework here. More replaced chips. The second connector, and you can see again all of this heavy solder buildup in places here on some of these. And whether that's an artifact of wave soldering, which this thing may have been wave soldered and just these wider areas picked up a lot of wave solder, or is intentional, I can't really say. They are wide traces. So definitely, I think, dealing with power. If we move on to a Sintra board, it's on, of course, a different, probably fiberglass looking at the board, although it may not be. Again, just a lot of TTL logic, a little row of transistors up here across the top, and just standard TTL logic from the 70s, 18th week of 70, third week, or 33rd week of 70, and just most of it just really common TTL stuff. There's a few TI parts down here, SN15862N. That may have been before TI adopted the 7400 series markings. I don't really know. Lots of 154s in it. They're all over in it, which is no surprise. Definitely a bodge of something added here, I believe. Maybe a little capacitor to take the edge off something, perhaps. Lots more TTL goodness. And finally, the other side of the board, and there seems to be potentially a bodge capacitor here too. It's down on what would be the ground rail here. Ground pins typically on the TTL devices are this bottom corner down here, with pin 1 being up here, and the power rails typically in this corner up here. That's not absolutely 100%. I've just noticed these two vices are in reverse, where these have pin 1 up, these two actually have pin 1 down. That's a little unusual. Typically driven by PCB layout. They just got a cleaner layout by rotating those two 7402s. So that's kind of interesting. If you repair a board like this, do pay attention. You notice there's no silk screen on the back side here to indicate what part goes where, or what pin 1 would be. So you definitely want to look for things like this. If you're repairing a board, taking a look at there's the logo a little closer up. Apparently revision E of the artwork. Some definite bodge wires on the back here. Looking at the little bit of resin or glue, whatever they mounted these down, they are most definitely factory, I believe. Looking at them, not unusual. That's the same two bodge wires. Hard to say if that's a bodge wire or expected in the design. There just may not have been a way to run a trace up there, and so it was designed to have the wire links put in. Maybe, maybe not. Lots of evidence of rework up here. I think that was all transistors up there. Let's go back and look at the center of the board. Yeah, big row of transistors up here. And if we come back to here, we can see the rework that occurred there. So parts have been replaced. So this thing's actually been repaired more than I initially thought. And kind of my first look through it. Another component there has been replaced. Another white wire. We kind of looked at these two again. Probably a bodge looking at it. It's coming off that IC pin and all the way around to this trace here. there's actually a trace under there. I suspect that's a bodge as well. They've gone to a via in the board to bring a signal down. Again, can't say absolutely. You can see again that the boards are keyed. There's a nice key slot here. We move on to what I believe is another Tektronix board based on the fact that it's blue. Again, lots more TTL logic. It's got these UL or micro L 93559 devices, 38th week of 69. Those are interesting, not sure what they are. And we've got this really pretty little grid here of transistors, which is kind of interesting to see. And we see the first two of the EA chipsets that ran the machine. It's a micro-coded machine. All of the really calculation logic's done in a series of, I believe, 6 of these white ICs here. That looks like a bodge here to me. It's interesting. It almost looks like a transistor is sitting there upside down with a pin clipped off. It's hard to say. Hard to say what they were doing there. Resistor, oh no, I see what it is. There was a transistor sitting here. There's a resistor here coming to what I would assume is the base of the device, perhaps. So yeah, that's definitely a bodge. And then there's this little bodge wire down here. Again, not uncommon for the era. Don't know if that resistor is intentional or not. It looks to me like they needed maybe a pull up here. What is it, 270 ohm perhaps? I'd say this is a negative power rail, potentially coming to, again, these lower pins down here. So if it is a negative power rail, it's just interesting, not sure what it's there for. You can see the boards are pretty densely packed. There's a little closer view of that array of transistors. I've been through the schematics as best I can. I don't really know what this array is. Lots more TTL logic. We get a little better view here of 5 of the Electronic Associates ICs. There's one more over here that's cut off that we'll look at in a minute. And like I say, these are really the heart. The ROM is here, the micro-coded engine to drive the thing. I think the memory perhaps lives in here as well. 4, 5, 6, 7, 8, 9. I don't know what this array here is. It's interesting. We looked at this bodge here a second ago. And you can see the component density. They're all the way down here. Even though there's not an edge connector down here, they've loaded components down here. It's actually a pretty dense board. Beautiful white ceramic devices with gold pins on them. I can't find data sheets on these. I suspect they're MOS devices, probably highly static sensitive. Not uncommon in calculator chips and chipsets. I've done a lot of Googling. They're part of a chipset, so there's CPM 3130s, and then there's dash 37, 32, 33, 34, 35-7, and I don't remember what the one over here is. But we'll find out here in a second. A little closer look at these. That's dash 7, that's dash 7, dash 7, dash 7. This guy doesn't appear to be dash 7. I have no idea what the red and purple dots somebody put on here are. Perhaps from factory test. Nice little array of 2N3251A transistors here. 15th week 71. Kind of another view of the same chips. And we finally see the dash 31. So it's again the same chipset, 3130-31, 51 week of 69. And it's got the Electronic Associates logo on it, which is really pretty cool. I wish I could find data sheets. You can see over here again, it's Tektronix. Kind of guessed that from the blue board. So it is Tektronix manufactured this board after they bought out Centra. Another kind of look at these white ICs that are the real heart of the calculator. Shot here to capture the markings on the board. Artwork Rev G. Copyright 71. Look at the back of the board. Looks pretty typical. I'm guessing bodge wire on here. There's some evidence again of some rework here, perhaps a replaced component. It's hard to say. These are awful dark and gray up here. It's hard to say if that's just the way they wave soldered or if there was some rework. I don't see flux like I do down here, so they may not be reworked. That same bodge wire. This connector, I don't know where it goes. Nothing's connected to it. I don't know if it's maybe a debug port perhaps, or for an option. The system could have a card with additional memory locations in it, and perhaps this was a jumper to that card. This unit doesn't have that additional board in it. Definitely some rework here. Just the amount of flux left in place there. This card was interesting because it doesn't have either. I can't tell if it says Sentra under there or it's in a. I just don't know what that is. ULECT. I don't know if this was a Sentra assembled board. It kind of looks like it might say Sentra under there. Although it's also been kind of whited out. I don't know. I don't think it's a Tektronix board. Again, just a sea of TTL logic with a few part numbers I don't recognize. Ceramic packages over here. I'm guessing they're just early TTL, like I've said a couple times before. The 7400 series markings kind of become the standard. CPN 3130-30. These are got to be part of that chipset from Electronic Associates, just because it follows the CPN number scheme. A couple of -30s here. There's a couple more -30s as we work our way across the board. Again, just more standard TTL. And the fourth, I think there's 4 total of these CPN 3130-30s. There's a nice tantalum capacitor sitting here. He's probably a target to be replaced. He will eventually fail. He hasn't exploded yet. A few driver transistors floating around here. Maybe they're doing level translation or something. I just don't know. It's without finding a data sheet for these, it's kind of hard to guess at what they do. There's a close-up of one of those 3130-30s. And a little closer view of the marking here. Kind of hard to guess. Back of the board. Some evidence of replaced components. There's, I think, a couple of resistors on the backside there, capacitors. Just little bits of evidence of repair. So this thing has, like I said, seen a lot more repair or rework than I initially thought. That looks like a trace repair there. Perhaps it blew some foil off when something failed. Nice little bodge wire here. Move on to another one of the Tektronix boards. It's got this, of course, the stamping here to tell us it's a Tech board. And of course, the blue PCB material and just a lot more TTL. Lots and lots of TTL. Another tantalum here. Should probably be replaced. Another little arrays of transistors here. I don't know if you've noticed going through this or not. The Tektronix boards are all, I don't know if these are nickel plated or solder plated or what edge connectors, and the Sentra boards I believe were gold plated. So, little difference there. These are most likely when I reseated the cards where I had the bad connections that were causing all the initial issues. Little 4x4 array transistors. Don't know. Schematic wasn't super revealing for this. Closer look at the transistors on the board. 3130-70. Again, there's that 3130 showing up and -7. Have to look at the back of the board. I was assuming transistors. These may have more pins. They may actually be ICs. Part of that 3130 chipset. You know, definitely 3130-7 matches and a -70 part. We'll look at the back of the board. See how many pins those have. Yeah, they're ICs. You can see the circular array here of pins. So these guys are definitely more than a transistor. They're definitely some kind of integrated circuit. Don't know. I wish I could find data sheets. It'd be interesting to know what these are, but you can see the three at the bottom we just looked there. There are their pads. A little bit of rework maybe at the factory. Solder joints didn't take well. Perhaps a couple of capacitors replaced or touched up. You know, I'm guessing these were probably at the factory. They touched up solder joints that didn't solder well. Again, that heavy copper or heavy solder on what I'm guessing is a ground. Based on where it goes to on the bottom, I'm suspecting that would be pin 1, 2, 3, 4, 5, 6 to 7, which would be a ground with power up here. So I'm guessing that's a ground rail. You don't see this heavy copper on these. Well, you do on a few of these wider ones. But I'm guessing maybe that was intentional, just to lower the resistance slightly. Look at the Nixie tubes. Oh, there's my phone dinging. Somebody's texting me. It's my birthday today, and I've been getting lots of birthday texts. So, I have no idea. Oh, I've got an appointment to keep here in a bit. Look at the Nixie tubes. I'm suspecting the issues with these not lighting up quickly. And I think you can kind of see some of the reason here is the tubes have gotten tired. A lot of the tubes are somewhat shiny inside. You can see these are darkened. And I don't know if that darkening, you can see the grid wires in here are pretty black. These may just be tired tubes, and it just takes them a while to come up. I think I will probably end up replacing the tubes. We'll see. So, and again, these tubes over here are the slow ones, and you can see how dark they are inside and how nice and shinier these are. And again, that's if you run the tube under voltage, you get, if I remember correctly, oxide buildup on the digits, which kind of lowers their intensity. There's a bit more resistance there, and if you run them too hot, you tend to sputter metal off, which I believe will coat the inside of the tube. Don't quote me on that. It's been a long time since I've dealt with Nixies, but I know under voltage or over voltage affects the life of the tubes at times pretty dramatically. There's that little ×10 indicator that's got, there's 200 volts coming into this. So it's got some kind of neon, some kind of discharge tube in here to light it up. So we can see the tops of the tubes here kind of looking down onto the PCB. One of the interesting things to note here is in an earlier video, I assumed the 74141 here was the digits driver for the Nixie tubes, because it is a BCD to Nixie driver. It takes a BCD input, and it takes one of 10 pins to ground, and those 10 pins typically go to the 0 to 9 digits in the tube. This guy's actually being used to drive the decimal points across all the tubes. So he's a decimal point driver. I found that kind of interesting. You can see where the edge connector that goes down on the top of the vertical board is soldered there. A little look here at some of the driver transistors. Over here we've got a 74145, and this is what's actually doing the decoding to the individual segments inside of the tubes. This board is multiplexed, so it's, driving each tube individually, one at a time. When the BCD value is brought up to here, it is routed to the tube that needs to be, well, it's routed to all the tubes in parallel, and then the high voltage is switched on the tube that they want to light, and that will ground the individual segment inside of the tube. So I was just surprised that the 145 was the digit driver, and the 141, which is I'm much more used to being a digit driver, was used to drive the decimal points. There's that 20 microfarad 250 volt cap that I have suspected was leaky. I actually did some tests to watch how fast this capacitor charged up. I've got some video here that will edit into this piece. It kind of shows how quickly this guy comes up and becomes stable versus the tubes struggling to light. So I've kind of moved away from thinking it's tired capacitors, although I will replace them just as a matter of course. Here's one of the edge connectors that goes down on the top of that vertical board. You can't see it well in the picture here, but it's at an angle to the surface of the board, because the board mounts at an angle relative to the vertical board inside. Part's been replaced. You can see where the Nixie tubes are soldered on here. Underneath the board, we can get a view of the center of the board here, where you can see the two connectors, and you again kind of get a hint that it's not in there square. Somebody's been replaced here. This side of the board, this is the 141. I believe he's been replaced at some point. Somebody else has been replaced here. You can get a little better idea here that there's a wide gap here under the edge connector. It's tilted this direction and it's closer to the board. I've got another shot here that maybe makes that a bit clearer, and then you can see, of course, the soldering for the Nixie tubes themselves. There's a shot there that kind of shows we've got the board down here, and you can see the angle these are canted up at. So those had to have been manually installed in that angle set, perhaps in a rig, I don't know. They've ground off the ears on these for some reason. Perhaps to allow them to get to the pins here and rework. I don't know. So on the back of the unit, there's a parallel interface board, and there could be a printer plugged into it. There's a bunch of peripherals that could be plugged into it. There was an external storage unit that I think used some kind of tape for storage, and they were all interfaced onto this edge connector. And what I've read, and I've interpreted it correctly, this thing supported up to 99 external peripherals. I'm sure it couldn't drive 99 on its own. There's just pretty much some standard kind of TTL logic here to drive this. I'm guessing these are TTL level signals. I don't really see enough on here to do level translation, and they just really are standard TTL devices. I think it's an 04, an 04, an 04, 7400, another 04, 15836 I don't recognize, 7400, 7404, 7404. There's just a bunch of inverters on here. And maybe these 7404s are being kind of used as drivers. I'd really like to understand the pinout of this and how to talk to it. I think I mentioned in a previous video I found a PhD thesis that covered somebody designing an external A to D and D to A, where he could sample. He could read in from the edge connector here and sample the A to D output, do some calculations on it, and output a different value to the D to A, kind of as like a PID controller kind of configuration. So it was an interesting paper to read through. There's schematics, fragments and stuff in it, but not enough detail to give me a hint what this connector is here. There is a Tektronix book that I have not found yet that covers this connector and how to interface to it. The good folks down at the Tektronix Computer Museum are going to hopefully Friday look through their microfiche catalog and see if they can find some of the manuals for this. They've been following along a bit in email as I've been doing repair work. The back of the PCB, I will probably keep this board out and just do some tracing. You can see some of the ICs come down to the connector. Some of them seem to go straight through to the edge connector. That goes straight through. So it's really hard to say, maybe there's latches behind here that latch something. Maybe it's just driven and a clock signal happens to pick up the address and the data from. I just don't know. So we're going to jump into the power supply here and take a look at it. We've got a line voltage switch here, 115 or 220. The big power transformer sitting back here. There's these little solder lugs that the transformer solder directly into, and then all the transistors sit on a heat sink here and are just soldered directly into these little lugs. I think it's kind of a nice construction. I kind of like the look of the power supply. When I replace these electrolytics, it will kind of spoil the look, but it is what it is. There's those big 10 volt, 10,000 microfarad that I think are for the 5 volt power rail. You know, here's a little 0.1 microfarad, 10%, 20 volt DC cap. Why there's those 200 volt little capacitors on the actual, what board was that on? That was actually on the keyboard. That just confuses me why there would be high voltage down there, unless they just had a bunch and they were just, you know, highly overrated. Other side of the board, the filter capacitors for the non-5 volt rail. This is the cap for the 200 volt rail for the Nixies. Kind of a clean construction here. You see a little DB9 connector up here, which is interesting. That brings the regulated power off the board back into the unit. I'm kind of looking in over the filter caps here to the row of edge connectors that all the boards plug into. That vertical Nixie card kind of decoder multiplexer sits in this first row. And then various boards sit in here. One of these positions isn't filled. I think it was that expansion card for additional memory slots and stuff. Edge connector on the other side. I believe this transformer here is probably the high voltage transformer for the Nixies. I don't know that definitively. It might be a tap off the big transformer. I just don't know. And maybe it's just a transformer for one of the rails they couldn't produce off the big transformer. It's hard to say. Kind of a look at how the transistors, you know, it's a linear power supply. So the voltage regulation is being done in these driver transistors. I think when we looked, there was 6.5 or 7 volts coming in. I believe 5 volts coming out and 5.3 that was kind of the control. I don't remember the pin out of the sky exactly, but we could see where there was a drive voltage coming in, a very close to 5 volt regulated voltage coming out. So I don't know if it's emitter collector base. I'd have to look at a data sheet. So the driver guys over here are tip 34s. And this one's a tip 33A, and again I measured 5 volts being regulated on it, which I found interesting. Maybe this was just a later replacement for a failed device. And then we've got these MCR 406s over here that I didn't measure any voltages on these as reference to the ground plane on the power supply, which kind of confused me. I don't really know what's going on here. One of the things the schematic didn't have was power supply, which is really kind of the part I'm focused on the most here. The 300 volt working is about 250 across in action for the Nixie tubes. Bulk filter cap, another look at their transistors used for voltage regulation. There's that DB9 connector that brings power from the supply into the backplane. Kind of an interesting choice to use a DB9 for this. Didn't get this shot really square, but there's the boxer fan in the back of the unit. I strongly suspect this boxer fan is original. It's really quiet. I mean, there's a little bit of noise to it, but it's really quiet. Super smooth when I spin it by hand. Like the bearings are still in excellent shape. This fan's potentially from 71. I was hoping to capture a date code here, and I didn't seem to. On the fan, if there is, it's down here where I didn't get the camera centered. I couldn't actually look through the viewfinder. I had to kind of snake the camera in and hope for the best in that shot. So that really brings us to the end of the photos. We'll move on next, just a couple of shots of me powering the unit up and looking at capacitors charge, and go from there. I hope you enjoyed this set, and we'll see you in a second in the videos. So I'm across the 40 microfarad 300 volt cap on the main PCB, power supply PCB, and I'm going to power the unit up here and just kind of watch the voltage as I power it up to see if it slowly climbs up or if it comes up to the, you know, around 300 volts instantly. So we power it up and it's jumping pretty quick. You can see it slowly climbing. The tubes are definitely not coming up here. Let's just see. Kind of trying to determine if this is a capacitor issue keeping the tubes from fully lighting, or if it's a just tired tubes, which is quite possible too. Now that came up really quick and is holding pretty steady at 270 volts. So I'm now measuring across the, I think it's 20 microfarad 250 volt cap that's up on the Nixie tube board itself. And again, I want to see if this takes a while to come up or if it comes instantly up to the 203 volts I think we measured before. So power's on. You can see it slowly climbing. Again, that came up pretty quick, so I'm starting to be more and more inclined towards these are just tired Nixie tubes. Although recapping it's still a really good idea. These are very old electrolytics that just need to be replaced as a matter of course. Tubes are slowly getting better. Back the power off, let it sit for a second here. So the voltage is bleeding back down up here. I don't know if there's a bleeder resistor across the high voltage supply or not. I'll let it finish bleeding off. We'll hopefully get focus on the tubes here. And I'll kind of show you the pattern that they wake up in. So it's actually better than it was a minute ago. You can see there's still one in there that's kind of blinking. And it'll slowly come up. So whether this is just tired Nixie tubes, and you can see it slowly becoming more and more solid. Let me go ahead and clear so it'll stop blinking. You can see there's definitely a brightness difference across them. This guy here is continuing to kind of blink inside. I don't know how well the camera's picking it up. They're becoming more and more balanced here. It's kind of slow. Let me enter an exponent. And those zeros came right up on the exponent. So again, the issue here may actually just be tired tubes. I think I'm going to go ahead and pull off the part numbers of the tubes. And assuming they're not horribly expensive, I think what I saw was there a few dollars a tube. Supposedly new old stock on eBay. I may just go ahead and order replacement tubes and retube this in a future video. Kind of undecided. Let it sit here for a bit. That capacitor is discharging. See, Nixie tubes don't get hot. They're not like a regular electron tube. Let it sit here a bit longer. We'll power it up one more time and capture it here. And see what we get. Now we can take a look a little closer at the internal capacitors. Those will both be replaced. I'm thinking they're probably in parallel based on voltage measurements. They are identical caps. The guy here in the center of the view is the gross filter cap for the high voltage supply. I think we measure running about 250 volts. And then there's a couple more back in here that are for different power rails in the system. There's this DB9 connector, I think is what it turned out to be, looking at the schematic, that brings the power off the power supply board into the system. There is no quick disconnect for the transformer leads here. So So this will be a little bit of a battle to recap. I'm still undecided if I'm going to remove the board or if I'm just going to clip the leads off the old caps and pigtail on. Removing the board would be cleaner, and I'm sure ultimately that's what I'll end up doing. Well, it's been off for a bit here. Let's see if I can capture the really slow wake up. Again, this is coming up much quicker than it did earlier. Clear it again. Again, that number 30 from the left. And it's slowly becoming more and more solids. I just don't know. These just may be really tired Nixie tubes. Don't honestly know. Anyhow, I just thought I'd share this little experiment with you. We'll talk soon.